Hey fellas, so today I'm going to introduce the basic terms and theorems that go along with circles. Okay, so it's basic introduction, just get you the basics, and then we'll get more in depth with later sections. So a circle, the definition of a circle is actually the set of all points that's equidistant from a certain point. Alright, so that one point is called the center. Okay, so the center of this circle is O. Alright, and a circle is created by finding all of the points, all the possible points that are the same distance away from that center point, right? And we know that distance is called the radius. We'll get there. Oh, it's right here. So the radius is that distance. So right here, the radius is that distance from the center of the circle to any point in the circle. So you could draw an infinite amount of radiuses in any given circle. Now the way you'd name this circle is you would call it circle O. Okay, so it's always going to be a little circle with a dot on it on the inside, and then the center of the circle next to it. So if I draw another circle here, circle A is the center, I would call it circle A. Okay, two circles are congruent as long as they have the same radius. So that's just if you take a circle, okay, and it's got some radius, let's say it's radius 2, right, and you pick it up and you slide it anywhere else in the world, and you don't change the size of it, and it still has radius 2, and that means those two circles are going to be congruent. Okay, so if I call this one circle B, and this one circle Y, then we'd have circle B is congruent to circle Y. Diameter is that distance that goes across the circle. Okay, so if we draw basically back-to-back radiuses, that's how you get a diameter. So if I draw that radius, and then the radius that is directly opposite of that, okay, that's going to be a diameter. It's going to go across the center, all the way across the circle in a straight line, and go through the center. So this diameter is something that you probably want to recognize the relationship between radius and diameter. The diameter is 2 times the radius. That'll be important for us to know. Now a couple other probably newer types of terms that go along with circles. All right, we have a chord. Okay, a chord is just any segment that connects two sides of a circle. So that would be a chord, that would be a chord, that would be a chord, right? Even this would be a chord, and notice that if you have a chord that goes through the center of the circle, that's going to also be a diameter. So diameter is a specific type of chord. Now, if you stick with that idea of going through the circle, but you don't stop there and you keep going, so that or this, all of those are called secants. Okay, so it has to intersect at two spots, but it doesn't have to end there. Right? It doesn't have to go on forever like a line like this one. It could also be a ray like this one, but it has to intersect in two spots. So all of these are examples of secants. The last one for these basic terms is called a tangent. A tangent is going to intersect the circle, but not at 2 points. It's only going to actually intersect at 1 point. Okay, so a tangent's going to hit just at 1 point, and it's got to go off to the sides. All right, so if you extend the line of a tangent, okay, it's never going to go inside the circle. So that'd be a tangent. This one would be a tangent. Right, that's a tangent right there. Okay, all types of tangents. Now, let me show you an example here in red of what's not a tangent. This is not a tangent. Okay, so even though it only intersects at 1 point here, if you extended this, it would go on the inside of the circle. So that is no good. Okay, that's not good. That's not a tangent. And this point at which these tangents intersect is called the point of tangency. Oops. Very simply, the point of tangency. All right. A couple of final terms and then the theorems. All right, tangent circles are going to be two circles that intersect at 1 point. All right, so if I draw this one and then this circle, right, those two circles intersect at this 1 point. That's the point of tangency. So those are going to be called tangent circles. Now those tangent circles could also be one inside of each other. Okay, we could have this one and that one. Okay, and they'll still intersect at this 1 point. All right, now concentric circles. Concentric circles are going to be coplanar circles that do not, or that have a common center but do not have the same radius. So if you draw like a target, They all have the same center, but they all have different radiuses. Okay, so each of these circles are going to be called concentric circles because they're all sharing the same exact center. But obviously that radius is different than that radius, and that radius is different than that radius, so on and so forth. All right, so the tangent radius theorem tells us that if you have a line that's tangent to a circle, okay, so I'll draw the tangent here in red. It's tangent to that circle. Let's just say that's tangent, right? Intersects at that point of tangency. And then you draw a radius from that point of tangency, okay? If that is actually a tangent, then this angle is always going to be a right angle, right? That radius and that tangent that intersect are always going to be perpendicular to each other. So this tells us that this is going to be a right angle. And if you think about it a little bit, you'll probably realize that what we're going to do with this is we're going to continue this, close it up, and create a right triangle, and then we'll be able to solve some things from that. And the congruent tangents theorem is the other one from this section. Tells us that if you take one point, right, you pick one point, and you draw both tangents, there's two tangents, hopefully you see, that you could possibly draw from that one point to that circle. If you draw both of those, there's one tangent, and there's the other tangent. Okay, they both intersect at the point of tangency. Right, this one's not very good. There we go, maybe out there. Right, if you have that, then those two tangents are going to be congruent to each other. So those segments are going to be congruent to each other. Okay, let's see this in action, some examples. So we're going to name each part of the circle. So we're just going to name what parts these are. Okay, so we've got CB here. If you think chord, that's correct, but more specifically, it goes through the center of the circle, so it's going to be a diameter. Okay, PQ here. PQ, you find it. It's going to intersect just at one point, so that's going to be a tangent. Okay, TS, right here, intersects at 2 points, doesn't go through the middle, so that will be a chord. Now, RT is the same segment, but continues on outside of the circle. Right, so since it goes to the outside of the circle and intersects at 2 points, it is a secant. And we see that AO here is a radius. Q right here, this point is the point of tangency. Okay, and O is the center of our circle. So those are all a bunch of different parts of a circle. Now, for tangents can intersect two circles at the same time. Okay, and if they do intersect two circles, then they're called common tangents. And common tangents could be both internal or external, depending on whether or not they cross through the circles or they stay on the outside of them. Okay, so we're going to identify each of these as a common tangent or not, and whether or not they're internal or external. Start here with EF. Okay, EF intersects this circle right here, but doesn't intersect this circle. Okay, so because of that, it's not even a common tangent, so that's going to be none, or neither. Right? If we look here at AB, okay, AB intersects this circle and this circle, and it crosses through the inside of the two circles as it hits them. Okay, so that tells us that it's going to be an internal tangent, internal common tangent. And CD differs from that because although it hits both of them, it doesn't cross to the inside. It stays on the outside on the same side of those two circles the whole time. So that would be an external common tangent. And a little tricky one over here, right? These are internally tangent circles, right? And it still intersects here. So you got to figure out if it's internal or external. Well, if it was internal, it'd have to go on the inside of these circles somehow. There's no way to draw that. It's staying on the same side on the outside, so that one's going to also be external. Okay, so if I tell you that AC here is equal to 10, I want to know, is BC tangent to circle A? Okay, so the way you'd figure that out is if it was tangent to circle A, we've got a radius drawn here, that tells us this would have to be a right triangle. Okay, so we, last chapter, learned how to figure out if something was a right triangle or not by using the converse of the Pythagorean theorem. So we've got 5 squared plus 8 squared. We want to know if that's greater than, less than, or equal to 10 squared. So we have 25 plus 64 and 100. 25 plus 64 is 89, which is less than 100, so this is not going to be tangent to each other. Now, to find the radius of a circle, we once again have a radius drawn here, that's r. We have another radius drawn here, that's r. We extend that radius to this point out here, q, and know that's 8, and then from q back to p, that's a tangent that we drew, okay, and that length is 12. So since it's drawn that way, we know that this has to be a right angle. Okay, so we see a big right triangle drawn here, and we can use the Pythagorean theorem to solve for r. So we're going to set this up. We've got r squared plus 12 squared. It's going to be equal to, but this hypotenuse, right, is not r or 8. It's actually r plus 8. Okay, those added together. So it's going to be equal to r plus 8 quantity squared. Okay, so r squared plus 144 is going to be equal to, we need to do r plus 8 times r plus 8. So when you FOIL that out, we've got r squared plus 16r plus 64. Okay, remember that the squared means you just have to multiply this by itself. So r plus 8 times r plus 8, you'd have to write as a product of binomials, and you FOIL that out to get r squared plus 16r plus 64. So when you subtract r squared from both sides, our r squared is going to cancel each other out. Subtract the 64 over, and we're going to get 80 equals 16r. Divide by 16 to get r equals 5. And lastly, we're going to find the perimeter of this quadrilateral. So in order to do that, okay, we have to notice that we've got two tangents drawn from each of these points, okay, which tells us that these two segments have to be congruent for all of these. So right here, 10.3 goes from here to here, so that means 10.3 is also going to be right there. 8.8 comes from here to here, so this one's also going to be 8.8. Right, this side was a little bit trickier. We know the whole thing is 21.8, and this little part is 8.8, so you could subtract 21.8 minus 8.8 to get this side, and you're going to be left with 13. So since this one's 13, that tells us this one also is 13. And to do the subtraction again, we've got 19.1 minus 13 gives us 6.1 for this side, which tells us this is also 6.1. Now, you can add all those up, and you're going to get the perimeter to be 76.4. All right, that's it.